Welcome to Flip Lesson 7.6. Today we're looking at factors and divisibility as we look at this idea. Once again, refreshing all these concepts, making sure we have them down as we learn, as we move into higher math. So first of all, we have the idea of factors. Factors, of course, being the whole numbers that divide a number without a remainder. What do I mean by that? Or what does that statement really mean? What is a factor? We look at the number 10 and we say, what do I do to get a product of 10? So which two numbers or factors when multiplied together equal 10? And as I work with that, I would quickly come away with this answer, right? 1 times 10 makes it equal 10. And then I also know that 2 times 5 equals 10. And so 1 times 10, 2 times 5, and we have this process to be able to find them. To do that, right, you start with 1, and then you multiply by the number itself, right? And then you think about numbers, right? This happens to be an even number, so I'm going to divide by 2. Next one up, right? 5. And then really the question is it divisible by 3? Of course, 10 is not divisible by 3. And we've come away with a response. All right, we start with an easy example just to solidify the idea. Go ahead and pause the video and find the factors of 18. From here, we can also get into bigger numbers, right? Now, 51 isn't a huge number, but it's a number that we look at and we say, okay, 51. All right, factors 1, 51. And suddenly we're at a point where it's like, what other number goes into 51? Or is it prime? Are there no other numbers? And it's easy to look at this and say, this is prime. There's nothing else. 51. That one's not in my memory banks. And it probably isn't, because if you were to investigate further, you would find that 3 is a factor, and it's times 17. And I don't think you memorized your tables up to 3 times 17. However, 3 times 17 does equal 51. So how do we look into numbers and find shortcuts to be able to understand if a number is divisible by a certain number? This is where we get what are known as our divisibility rules, right? And we can talk about these as we look at this real quick. So first of all, we have this set of rules. First of all, a number is divisible by 2 if the last digit is even. So all even numbers are divisible by 2. Okay, a number is divisible by 4 if the last 2 digits can be divided by 4. So for example, 51, right? 51 is 51 divisible by 4. The answer is no. So of course, as we already discovered, it's not divisible by 4, right? I could throw another number up here. 112. Okay, last 2 digits, 1 and 2. Is that divisible by 4? The answer is yes. So 112 is divisible by 4. Right? So we have that concept. From here, we move on and we see, oh yeah, we're not done. Lots of them. Number 8, right? Last 3 digits can be divided by 8. And so this is where we're getting to really big numbers and wondering if they're divisible by 8. And this is where this rule comes in. And it can help us to determine numbers a little bit simpler as we're dealing with really big numbers. Okay. Back to some easier ones then, right? 5 if the last digit is 0 or 5. Right? 10 if the last digit is 0. Right? Those ones are pretty standard. You've been learning those since, well, probably since you've been learning to count, right? Way back in kindergarten. And then we get into the ones that are really good, but they have a tendency to make us think just a little bit more. And so that's going to be if the sum, right? Here's the key word there. The sum of the digits can be divided by 3. Right? So this is why our 51 really becomes a great example, because I take 5 plus 1, which equals 6, and 6, of course, is divisible by 3, which means 51 is divisible by 3. And we discovered that that was 17. Right? If the numbers can be divided by 2 and 3, so it has to be an even number. That's what's going to make it divisible by 2. And then has to follow this rule right here to be divisible by 3. And finally, you have number 9, if the sum of the digits can be divided by 9. Right? And so this goes into adding up your digits again, just like we did for the 3, but this time we want to divide by 9. So here is one set of rules that helps us out, but that's not it, right? As you record all those, put those into your little cheat sheet for the year, right? Here's a few more, right? A few more. These ones are going to help us with our zeros, right? With the number ending in 10 is divisible by 2. Of course, that means it's even, right? But here's a couple other neat little tricks that we can use, we want to put into our memory banks. 2 zeros is divisible by 2 and 4. And 3 zeros is divisible by 2, 4, and 8. Right? So when we see those numbers, when we use those numbers, we're going to be able to apply them. All right, now that we got all this information, all these rules, all these great strategies, and they came at you real fast, but let's put them to use in this sample problem. It says which whole numbers from 1 to 10 are divisors of 9,060. So your goal right now is to figure out which numbers, or what are the factors basically. I guess you don't need to find both sides, you just got to find the divisors. Between 1 and 10, so is 1, is 2, is 3, and so on. That's the question you're being asked there. Go ahead and pause the video and solve that one. The last part of this then is working with what's known as finding common factors, and particularly finding the greatest common factor, so that when we take numbers and we break them down into factors, right? I take the number 12, I break it down into factors, right? 12 is 1 and 12, 2 and 6, and 3 and 4. I'll throw some commas in there just to separate out the numbers. Those are the factors. Then I take 32 and say 1, 32, okay, it's divisible by 2, and it's going to be 16, right? And then it's going to be divisible by 3, right? 3 plus 2 is 5, so it's not divisible by 3, right? I know it's divisible by 4, though, and it's going to be 8, and in the end, that's going to be the end. So 1, 2, 4, 8, 16, 32. But now we're looking at what's known as the GCF, greatest common factor. And so I look at my two lists of numbers here, and I say, okay, 32 doesn't match, 16 doesn't match, 8 doesn't match. Oh, here we go, a 4 and a 4. That becomes the GCF of 4. And so we have that concept also. All right, one final sample problem to get you on your way as you're dealing with factors and divisibility. Go ahead and use those divisibility rules to help you out as you find the factors and work with this concept. That's it for lesson 7.6.